Hello friends, IBM is here with the last episode of particle physics. I guess this will be the last episode of particle physics. This is AS Physics 9702. Multiple choice questions, those are for paper 1. This is specifically going to be atomic physics and atomic and particle physics. These are always the last multiple choice questions in paper 1, multiple choice. The last questions in paper 1, the last 3 or 2 questions are particle physics. So in part 2, we stopped on page, I think, 31. Let's proceed from page 31. Alpha particle, alpha, beta, and gamma radiations have various depths of penetration in matter and different charges. Which row best summarizes the penetration and charge of each? We know the charge of an alpha particle is plus 2e. So this one is saying absorbed by a sheet of card, negative charge. That is not true. Beta particle have no charge, so it means we have eliminated A because alpha particles have charge. B, absorbed by a sheet of card, negative charge. Alpha particles are positively charged. That is not true. C, absorbed by a sheet of card, positive charge. So these ones are correct. Beta particle absorbed by several millimeters of aluminium. That is true. They have a negative charge. Not fully absorbed by several centimeters of lead. That is true. They have no charge. So the answer is going to be C. Gamma radiations are not fully absorbed by a few centimeters of lead. And most of them are absorbed, but not fully. And they have no charge. In 2002, two-proton radioactive decay of an isotope ion Fe4526 was observed. What could be the resulting product? A two-proton radioactive decay, two-proton radioactive decay of an isotope ion was observed. Because it was a two-proton decay, the proton number must have reduced by 2. So the proton number reduces by 2. That means this one is not correct. This one is not correct. But since a proton is written as P11, if the proton number reduces by 2, so nuclear number must reduce by 2. So this should be 43. So the answer is going to be B. U++ is a doubly ionized uranium atom. The uranium atom has a nuclear number 235 and a proton number 92. In a simple mode of the atom, how many particles are in the ionized atom? How many particles are in the ionized atom? So it is a doubly ionized uranium atom. The uranium atom has nuclear number 235. And in a simple mode of the atom, how many particles are in the ionized atom? Remember, when we talk about number of particles, this includes proton number, neutron number, and the number of electrons. So number of protons is 92. Number of neutrons is going to be 235 minus 92, which is 143. And the number of electrons, the number of electrons is, because it is ionized, the number of electrons is most likely going to be 90 because it is a doubly ionized. That means number of electrons is going to be less than the number of protons by 2. So we can sum up and verify 92 plus 90 plus 143. That is 235. So the total number of particles is 300. Total number of particles 325. So we just sum up these. Because it is doubly ionized and it is U++, it means the proton number is the number of electrons is less than the proton number by 2. The grid shows the number of nuclides arranged according to the number of protons and the number of neutrons in each. A nucleus of nuclide lithium decays by emitting a beta particle. I mentioned that every time they just mention a beta particle, just know it is beta minus. What is the resulting nuclide? So a nucleus of lithium 8,3 decays by emitting a beta particle. Beta particle is beta 0, -1. So what is the resulting nuclide? So nucleon number is not actually going to change. The grid shows the number of nuclides arranged according to the number of protons and the number of neutrons in each. So we have lithium, a nucleus of the nuclide lithium decays by emitting a beta particle. So this is going to be beta. Okay, this is going to be 8, and this is going to be 4. That is going to be 4 number of protons. So the number this is given as number of protons against number of neutrons. So number of protons, A has 4 protons, so it means we are in this row here. And A has how many neutrons? Neutrons are going to be 8 minus 4, which is equal to 4. So we are in this column here. So the answer is going to be A. So A has 4 protons, that means in the first row, and 4 neutrons, that means in this row here. So it means it's going to be A. A nucleus X decays into a nucleus Y by emitting an alpha particle followed by 2 beta particles. Which statement about this nuclear decay is correct? Which statement about this nuclear decay is correct? Beta particle decay occurs when a proton changes into a neutron. A proton changes into a neutron. Which statement about this nuclear decay is correct? A nucleus X decays into a nucleus Y by emitting alpha particle followed by 2 beta particles. Beta particle decay occurs when a proton changes into a neutron. It can also be a neutron changing into a proton, so that is not correct. Nucleus Y has the same nucleon number as nucleus X. That is not true because an alpha particle reduces the proton number by 2. Then the beta particle increases the proton number by 2. But then the alpha particle reduces the number of nucleons by 4, yet the beta particles do not affect the number of nucleons, so that is wrong. Nucleus Y is an isotope of nucleus X. That is true. The alpha particle reduces the proton number by 2. The 2 beta particles reduce the proton number by 2. So it means the total number of protons will go back to the same as those of X. So nucleus X and Y are isotopes. Or nucleus Y is an isotope of nucleus X. Total mass of the product is equal to total mass of the initial nucleus X. That is not true. A slow-moving neutron collides with the nucleus of uranium-235. This results in a nuclear reaction that is represented by the following nuclear equation. What does X represent? So here we just balance the equation. So on the left, proton number is 92, on the right is 60 plus 32. Proton number is conserved. So X should not be having any proton number. So it must be, most likely it should be related to a neutron. It should be related to a neutron. So it means we can't say electrons because it affects proton number. We can't say protons, it affects proton number. So we have 1 neutron and 2 neutrons. Let's now conserve nuclear number. 235 plus 1 should be 154 plus 80 plus the nuclear number of X. So because the proton number is 0, the nuclear number must be 1. But how many particles of X? So we have 235 plus 1 minus 154 minus 80. So those are 2. So the particles of X, if I call that A is equal to 2. So this is going to be N10 times 2. So there are 2 neutrons. The first artificial radioactive substance was made by bombarding aluminium with alpha particles. This produced an unstable isotope of phosphorus 3015. What was the byproduct of this reaction? The first artificial radioactive substance was made by bombarding aluminium, so aluminium 2713 with alpha particles, so plus alpha, which is 4, 2. The product this produced an unstable isotope P3015. What was the byproduct of this reaction? So plus X, so proton number. This is on the left, it is 31, the other one is 30, so that is 1. Make it 31. Then on the left, proton number is 15, this is 15, so that is 0. So that is going to be a neutron. So this is going to be a neutron. An isotope of thorium has a nucleon number 234 and a proton number 90. It decays to form another isotope of thorium with a nucleon number 228. How many alpha particles and beta particles are emitted? So it is an isotope. Proton number should be the same. So TH. Even if I don't know the symbol for thorium, this is for chemistry, knowing the symbols. 232, 90. It decays to form another isotope. It decays to form another isotope. Let me call it X with the nucleon number 228. Because it is an isotope, the proton number is going to be 90 plus how many alpha particles and how many beta particles. So let's say it produces X alpha particles, that is 42, plus Y beta particles, that is 0, negative 1. So conserving a nucleon number to find X, we shall have that 228 is equal no, it's not 228. 232 should be equal to 228 plus 4x plus 0y. So we find x. 232 minus 228 divided by 4. So x is 1. So there is only one alpha particle emitted. So x is equal to 1. So one alpha particle, we eliminate D and A. So then we see how many beta particles. Now we conserve the proton number. 90 on the left hand side is equal to 90 plus 2 times x, that is 2. Then plus y times negative 1, that is negative y. So you see that negative y is equal to negative 2. So y is 2. So the answer is going to be C. 4 nuclei are represented below. Which statement about these nuclei is correct? An unchanged atom of element Q has 24 orbital electrons. Q. The number of electrons should be the same as number of protons. That is wrong. Nucleus M could transform into Q by emitting a beta particle. M into Q by emitting a beta particle. Let's see. M, if it transforms into Q by emitting a beta particle, see they have different nucleon numbers. Yet beta particles not change the nucleon number, so that is also wrong. Nuclei G and M are isotopes of the same element. G and M, they are not isotopes because they have different proton numbers, so they are not isotopes. When E absorbs a neutron and then emits an alpha particle, nucleus E transforms into M. That could be the correct answer. We can just verify. They have said E absorbs a neutron, so plus a neutron N10. E is 2814. It absorbs a neutron. Let's see if what it gives. They said and then emits an alpha particle, so plus alpha, that is 42, plus another nucleus. So proton number should be 12. The proton number should be 12, and the nuclear number on the left, it is 28 plus 1, which is 29, minus 4, which is 25, and that is strictly nucleus M. So that is D. Which statement about alpha particles is correct? Alpha particles emitted from a single radioactive isotope have a continuous distribution of energies. That is wrong. It is beta particles with a continuous distribution. Alpha particles have discrete. For alpha particles, the energies are discrete. Alpha particles have less ionizing power than beta particles. That is not true because alpha particles have more charge, so they are more ionizing. The charge of an alpha particle is positive 1.6 exponent negative 19. That is not true because the charge is positive 2e. So it is 2 times 1.6 exponent negative 19. The speeds of alpha particles can be as high as that. I think we have already proved this. This is just a repetition. The isotope Rn22286 decays in a sequence of emission to form isotope 20682. At each stage of the sequence, it emits either alpha or beta. What's the number of stages in the decay sequence? So let's see. Number of stages in the decay sequence. So Rn22286 decays to give us Pb 20682. Let's just find how many alpha particles are emitted and how many beta particles are emitted. The total will be the number of stages in the decay sequence. So plus X alpha particles for 2 plus Y beta particles. Remember beta is negative. So it is the alpha particles will determine the nucleon number of Pb. So 222 is equal to 206 plus 4x. So we can find x, 222 minus 206 divided by 4. So x is 4. X is 4. We have 4. We expect a maximum of 4 alpha particles. Let's check y. So we conserve proton number 86 equals to, this was 82 plus x is 4. So 4 times 2, that is 8 plus negative y. So we have 86 minus 82 minus 8, that's negative 4. So negative y is equal to negative 4, y is equal to 4. So the most possible number of stages is 4, because it emits 4 alpha particles, it means those are 4 stages, and 4 beta particles, those are other 4 stages, giving us a total of 8 stages. What's the approximate mass of a nucleus of uranium? Mass of a nucleus of uranium. The approximate mass of a nucleus of uranium is about 10 power negative 25. In fact, you just look at, you estimate that it has how many protons. Uranium has how many protons? Approximately uh, approximately 92. And how many neutrons? Or you can just look at it as 235U. 235 times 1.66 times 10 power negative 27. So you can check 235, or you can say 236, 238 times 1.66 exponent negative 27, that is 1U, which is 3.9 times 10 power negative 25. So the mass is of the order 10 power negative 25, because the mass of the nucleus in unified atomic mass unit is just that value. Since we are used to uranium as 235 or 238 or 236, you just change that times 1.66 times 10 power negative 27 to get the order. So that is C. The nucleus of a radioactive isotope of an element emits an alpha particle. The daughter nucleus then emits a beta particle, and then the daughter nucleus of that reaction emits another beta particle. Which statement describes the final nuclei that is formed? So X emits an alpha particle, alpha 4, 2, plus Y. So Y, this is A minus 4, Z minus 2, because this is A, this is Z. Then Y is A minus 4, Z minus 2. The daughter nucleus then emits a beta particle. So this gives us, let's say, P plus beta particle. Whenever it is not mentioned beta plus, it is beta minus. So this one will be A minus 4, and this one will be Z. Because this is minus, this will be Z minus 2 plus 1. The proton number increases by 1. Then, again, this one emits another beta particle. So P, that is A minus 4, Z minus 2 plus 1 is minus 1. It emits another beta particle, 0, negative 1. So it emits another particle, 0, negative 1, to give another nucleus Q, which is A minus 4, and this will be Z plus 1. Z minus 1 plus 1. So that we go back to Z. So proton number was initially Z minus 1, but because it has emitted a beta minus, this becomes plus 1, which takes us back to Z. So this is just Z. So it is an isotope. So we are saying which statement describes the final nuclei that is formed? It is a different isotope of the original element. That is very true. It is a nuclide of a different element of a higher proton number. The proton number is the same. It is a nuclide of the same element but with a different proton number. That is not true. It is identical to the original nuclide. That's not true because they have different nucleon numbers. A nuclear reaction is shown here. What is product X? So we just balance. Proton number 94. This is balanced. So this is going to be 0. Nucleon number is 242 minus 241. That is equal to 1. So that is a neutron. It is a neutron. Alpha, beta, and gamma radiations are absorbed to different extents in solids, behave differently in an electric field, behave differently in a magnetic field. The diagrams illustrate these behaviors. So we see, of course, this is going to be gamma, this is beta, and this is alpha. Here, we explain that this Q is gamma, R is going to be alpha, P is going to be beta. Because beta has a small mass, it undergoes a greater deflection. Then that was in an electric field. In a magnetic field, this is going to be gamma, this is going to be alpha, and this is going to be beta. Which three labels on these diagrams refer to the same kind of radiation? Let me see. L, alpha, P is beta, X is alpha. So that is not true. L is alpha, P is beta, Z is beta. That is not true. M is beta, P is beta, Z is beta. So the answer is C. What is the approximate mass of an alpha particle? An alpha particle has a mass of 4U. It is a helium nucleus. It is 4 times 1.66 times 10 power negative 27, which will give us, we can check, 4 times 1.66 exponent negative 27. So that is 6.6 times 10 power negative 27. 6.6 times 10 power negative 27. So this is most likely going to be this one here. Let me repeat, 4 times 1.66 times 10 power negative 27. Yeah, this is most likely going to be this. It can be less than, it can be slightly greater than 1.6. It can be slightly greater than 1.6 times 10 power negative 27. Okay. An actinium nucleus has nucleon number 227 and a proton number 89. It decays to form a radium nucleus emitting a beta particle and an alpha particle in the process. What are the nucleon number and proton number of the radium nucleus? So, actinium, I'll just use I don't know the symbol, maybe it is Sc227. Proton number is 89. Decays to form radium. I think radium is Ra. We don't need these symbols, they are for chemistry. We just need to know how to deal with these nucleon numbers and proton numbers. So because it emits a beta particle, beta minus, every time they don't tell which particle it is beta minus. Then and an alpha particle in the process, so alpha is 42. So proton number, because this is 89 on the other side, and this is -1 plus 2, which is 1, so this is going to be 88. So without going any further, the proton number is 88, so the answer is going to be B. You can verify the nucleon number 227 minus 4, which is 223. An econucleus can be transformed by a process termed decay capture. In this process, the nucleus absorbs an orbital electron. The nucleus absorbs an orbital electron. In no other process, if no other process is involved, what is the resulting nucleus? So let's see K capture, nickel, 59, 28. It is capturing an electron E0, -1. If no other process is involved, what is the resulting nucleus? So the resulting nucleus will be X, 59, and this will be 27. So it will be 5927, which is going to be cobalt. It was once thought that mass of an atom is spread uniformly through the volume of the atom. When alpha particles were directed at a piece of gold foil, the results led scientists to believe instead that nearly all the mass of the gold atom is concentrated at a point inside the atom, which effect is possible only if nearly all the mass of the gold atom is concentrated at a point. 1. A few alpha particles bounce back. Most alpha particles are only slightly deflected. That is not true. Some alpha particles pass through without any deviation. They said which effect is possible only if nearly all the mass of the gold atom is concentrated at a point. Some alpha particles are absorbed. That is the worst option here. Some alpha particles pass through without any deflection. Most alpha particles are only slightly deflected. A few alpha particles bounce back. That is only if nearly all the mass of the golden atom is concentrated at a point. A few will bounce back. So the answer is going to be A. Which pair of nuclei are isotopes of one another? So isotopes have the same proton number. So we just find the proton numbers. So let's check. So we have 186 minus 112. That is 74. We have 180 minus 118. That is 62. We have 186 minus 112. This is 74. We have 182. 182 minus 108. That is 74. We have 184 minus 110, which is 74. We have 187 minus 110, which is 77. We have 186 minus 110, which is 76. And 186 minus 110, which is 186 minus 110, which is 74. 186 minus 112, which is 74. So nuclear number, these ones are not isotopes. These ones have the same proton number. These ones are not isotopes. These ones are not isotopes. So the answer is going to be B. Scientists investigating the count rate from a radioactive source observed that the count rate fluctuates. What do these fluctuations imply about the nature of radioactivity? That one is just the random nature of radioactivity. So it is random. When you say it is not predicted, it is not predictable. It is actually it is hard to predict which nucleus in a given sample will decay next. But the fluctuations can be because the decay is actually random. But that part of nuclear physics is now, that part of atomic physics is now under nuclear physics in A level. Spontaneous means not affected by environmental factors. So this one means not affected by environmental factors such as temperature, pressure, chemical catalysts, etc. The decay of a nucleus of neptunium is accompanied by emission of a beta particle and gamma radiation. I said whenever it is beta particle without mentioning plus or minus, it is always beta minus. What effect, if any, does this decay have on the proton number and on the nuclear number of the nucleus? What effect, if any, does this have on the proton number and on the nuclear number of the nucleus? It is the decay of the nucleus is accompanied by emission of beta particle and gamma radiation. Gamma radiation does not affect the nuclear number and proton number. Beta particle does also not affect the nuclear number. So the nuclear number does not change. So we just look at no change in nuclear number, and that means this is going to be the answer. Because beta does not affect, because beta is beta, 0, -1. Gamma does not affect. So the nuclear number is not changed. And that code, the row which has unchanged nuclear number is the last row. When alpha particles are fired at a thin metal foil, most of the particles pass straight through, but a few are deflected by a large angle. What change would increase the proportion? We have answered a similar question. Some of these questions are just a repeat because there are not many questions in particle physics, so the examiner repeats the questions many times. So I tried to eliminate them, but I couldn't see all of them because I was rushing. So which change would increase the proportion of alpha particles deflected by a large angle? Using alpha particles with greater kinetic energy, that one actually decreases the proportion. Using a foil made of a metal wire with fewer protons, that one also decreases because it reduces the charge. Using a double thickness foil, this one increases because double thickness means there are now more atoms, there are more nuclei, so a greater chance of deflection is obtained. Using an alpha source with higher activity, that one just increases the number of alpha particles emitted. Plutonium decays by emitting gamma radiation. Which nuclide is formed from one of these decay reactions? So it is emitting alpha radiation. So proton number reduces by 2. So this one is wrong. This one is wrong. And the nuclear number reduces by 4. So that means the answer is going to be A. A nucleus of a nuclide Sc decays by emitting a beta particle. The nuclear equation below represents this decay. Which pair of values of x and y is correct? So it is a beta particle, so it is 0, -1. So y should therefore be 89 plus 1, that is 90. Y should be 90, so the answer is D. Because y should be 90, the rest are not 90, so the answer is D. Two alpha particles with equal energies are deflected by a large nucleus. Which diagram best represents their paths? The nucleus with the alpha particle which is closer to the nucleus undergoes more deflection, so this is wrong. It can't be deflected towards the nucleus. It can't be deflected towards the nucleus. So the answer is simply A. Because they are repelled, they can't be deflected towards the nucleus. Which experiment? An experiment in which alpha particles were deflected by gold foil produced new insights into the structure of the atom. Which conclusion can be drawn from the results of the experiment? Atomic nuclei occupy a very small fraction of the volume of the atom. I think that is very true. Atomic nuclei occupy a very small fraction of the volume of the atom. Electrons orbit the atomic nucleus. Which conclusion can be drawn from the alpha particles? We can't draw this, although it is true. We can't draw it from the alpha particle experiment. Some atoms of the same element contain different number of neutrons. That is true, but we can't confirm it from that experiment. The atomic nucleus contains protons and neutrons. That is true, but we can't confirm it from the alpha particle scattering experiment. Another experiment or other experiments have carried out to confirm that. Nuclear decay is both spontaneous and random in nature. Which law gives the correct experimental evidence for these properties? Spontaneous. Remember, spontaneous, not affected by environmental factors. The decay rate is not affected by pressure, that is spontaneous. The decay rate is not affected by pressure, that is spontaneous. The decay rate is not affected by temperature, that is spontaneous. The rate at which radiation is received at a counter fluctuates. This is random. That one is random. So we have eliminated D because the rate at which radiation is received at a counter fluctuates. That is random nature. Then let's look at the random nature. The decay rate is not affected by temperature. That is spontaneous, not random. The rate at which radiation is received at the counter rate fluctuates. That is random. The decay rate is not affected by pressure. That is spontaneous, and this is also spontaneous. So the answer is only B. Radon 22286 is the start of the decay chain that forms bismuth. We have done this question. We are repeating it. Let's just answer it very fast. By alpha and beta emission. For the decay of each nucleus of radon, how many alpha particles and beta particles are emitted? Okay, so radon Rn 22286. It is going to give us bismuth 21483 plus a given number of alpha particles, which I'm calling X, plus a given number of beta particles, which I'm going to call beta 0, -1. The number of alpha particles will be determined by the nuclear number because it is only alpha particles which change the nuclear number. So we have 222 equals to 214 plus 4x, because alpha particles are x times 4. That is the nuclear number. So 222 minus 214 divided by 4. So there are two. We agree that there are two alpha particles, so we ignore A and C. Ignore A and C. So we remain with only D and B. Let's check the proton number. On the left hand side it is 86, which is equal to 83 plus X is 4, remember. X is 2. X is 2. So this will be 2 times 2, which is 4, plus Y times -1, which is -Y. So 86 minus 83 minus 4, that is going to be -1. -1 is equal to -Y. So Y is 1. So Y should be 1. So the answer will be B. A nuclear isotope emits radiation which is detected by a GM tube or Geiger-Müller tube held at a distance of about 10 centimeters from the radioactive source. The radiation is stopped completely by 2 millimeters thick sheet of lead. Completely. What can be deduced from this information about the emission from the isotope? Okay, so it could be alpha and beta radiation, but not gamma. It could be alpha and beta radiation, but not, and gamma radiation, but not beta. It could be beta and gamma radiation, but not alpha. They say the radiation is stopped completely. Of course, alpha must be stopped completely. So when you say but not alpha, then that is not true. Then it could be alpha, beta, and gamma radiation. Not at all. Not all of them. Because we know alpha is stopped and beta is also stopped. So it means it is only gamma radiation which may not be stopped by a few millimeters of thick sheet of lead. A few millimeters. 2 millimeters is very small. So it could be alpha and beta, but not gamma radiation. So the answer is A. Because gamma radiation can travel even through a few millimeters of lead. What remains constant during beta minus emission from a number of identical nuclei in a substance? So the nuclear number does not change. Beta minus emission does not affect the nuclear number. So the nuclear number of the nuclei does not change. The graph of neutron number against proton number represents a sequence of radioactive decays. So nucleus X, it is losing 2 protons from 84 to 82. Nucleus X is the start. So proton number changes from X, it changes from 84 to 82. Nuclear number changed from 134 to 142. That is beta particle emission. Those are 2. If the proton number has reduced, that must be 2 beta plus particles. Then again, the proton number increases to 84, and the nuclear number, sorry, this is neutron number, not nuclear number. So number of neutrons, let's first verify. So X, proton number is 84. Nuclear number is 132 plus 84. 134 plus 84. So that is 218. It is now giving us a nucleus, let me call it Y or P. Proton number is 82, and the nuclear number is 82 plus 132. So this is 214. So this must be an alpha particle plus alpha 42. So it has decayed by emission of alpha. Then P, which is 82,214, is now giving us Y, which proton number is 84, and nuclear number is 84 plus 130. 84 plus 130, which is 214. So the nuclear number has not changed, but the proton number has increased by 2. So this must be beta 0 negative, but there are 2 of them. Because 2 times negative 1, that would be negative 2, reducing 84 to 82. Okay. So what is emitted during the sequence? So it is 1 alpha particle followed by 2 beta particles. So 1 alpha particle followed by 2 beta particles. So the answer is B. A class of students used dice to simulate radioactive decay. After each throw, those dice showing 6 were removed. The graph shows the results. What would the scatter of points about the best fit curve represent for actual radioactive decay? I think that is random nature. The scattering of the graph is random nature. So that is random nature of radioactive decay. So this is going to be random nature. That is scattering. Scatter of points about the best fit curve. Which statement about alpha, beta, and gamma radiation is correct? Alpha radiation has the greatest ionizing power. I think that is very true. Beta has the greatest ionizing power, not true. Gamma radiation has the greatest, not true. Alpha, beta, and gamma radiation have nearly equal ionizing powers. That's not true. So the answer is going to be A. In a radioactive decay series, 3 successive decays each result in a particle being emitted. The first decay results in the emission of a beta particle. The second decay results in the emission of an alpha particle. The third decay results in the emission of another beta particle. Nuclides P and S are compared. Which statement is correct? When the beta particle is emitted, okay, let's just write an equation here. P changes to Q by emission of a beta particle. If this is A and this is Z, if it emits a beta particle, so this one proton number is going to be Z plus 1. This remains A. Then if this emits an alpha particle to form R, proton number is going to be, nucleon number will be A minus 4. Proton number is going to be Z plus 1 minus 2. Because it was already Z plus 1 when it emitted a beta particle. Then if this emits S by beta minus emission, nucleon number is not changing, it is A minus 4. Proton number, remember this one is giving us Z minus 1. So since it is beta minus, proton number increases by 1, so this is Z minus 1 plus 1, which takes us back to Z. And that means the proton number is the same as the first one, so those are isotopes. P and S are isotopes of the same element, so the answer is B. A material contains a radioactive isotope that disintegrates solely by the emission of alpha particles at a rate of 100 seconds, 100 per second. Which statement about this material is correct? We have answered this question. If it disintegrates solely by emission of alpha particles at a rate of 100 per second, 100 per second, and an alpha particle is He, it is 42. So if it emits by emission of alpha particles at a rate of 100 per second, then it means the number of nucleons in the material diminishes at a rate of 400 per second. The number of nucleons in the material diminishes at a rate of 400 because for every alpha particle, the number of for every 100 particles, the number of nucleons reduces by 4 times 100, which is 400. So the answer is going to be C. A different nucleus can be formed by bombarding a stable nucleus with an energetic alpha particle. Sodium is bombarded with an energetic alpha particle. What could be the product of this nuclear reaction? So sodium 2311 is bombarded with alpha, which is 42. So this should give us a nucleus. Let me call it X. So this should be a proton number, should be 227, and this should be 13. So let's check. Let's check. So I think here the answer is straight away, it is D. So proton number 2713 plus gamma, because gamma does not change the proton number. But when you check this, a beta is 0, -1, so there is no balance. A proton is P11, there is no balance in the proton number. A neutron is N10, there is no balance on the left-hand side, so the answer is going to be D. The first artificial radioactive substance was made by bombarding aluminium with alpha particles. This produced an unstable isotope of phosphorus. So let's bombard aluminium 2713 with alpha, which is 42, to form P, which is 3015, plus another product, a byproduct. We balance the equation. 15, this is 15, so X will not have any proton number. 27 plus 4, that is 31, so x will be 1. So that is going to be a neutron. X10, that is a neutron. Uranium-235 decays by alpha emission into a daughter product, which in turn decays by beta emission into a grand daughter product. What is the grand daughter product? We have done a similar question before, but we can still repeat it. Uranium-238, 92, is emitting X by emission of alpha 42. So this is going to be 234 and this is going to be 90. Then X, which is 234 and 90, again emits beta minus to form Y. Beta minus is 0, negative 1. So this will be 90 plus 1, 91, and this remains 234. So the answer is going to be B. Which statement about nuclei is correct? Different isotopic nuclei have different proton numbers. That is not true. If they are isotopic, they have the same number of protons. For some nuclei, the nucleon number can be less than the proton number. That can never be true, because a proton is one of the nucleons. In some nuclear processes, mass energy is not conserved. That is not true. In all nuclear processes, mass energy is always conserved. So it means our answer is going to be D. Nucleon numbers of nuclei are unchanged, but by the emission of beta plus, because beta plus is beta 01, so the nucleon number will always not be changed. The uranium nucleus undergoes alpha decay, producing nucleus X. X undergoes beta decay, producing nucleus Y. For nucleus Y, what are the values of proton number and nucleon number? So we see uranium 238, 92 is undergoing decay to produce X by alpha emission. So plus alpha 42, so this is 234, this is 90. X 234, 90 is emitting, is forming Y plus a beta particle. Remember I said every time they just mention beta, it is beta minus 0, negative 1. So this is going to be 91 and this is going to be 234. So we subtract 234 minus 91 to get the number of neutron. No, they wanted the nucleon number. So nucleon number is the number of protons is 91. The number of nucleons is 234. So the answer is C. Radon-22 is radioactive and decays to give to polonium-216 with the emission of alpha. The equation is shown here. How many neutrons are in the radon and polonium nuclei? We want neutrons. So we just subtract. For radon, 220 minus 86. That's 134. So I think the answer is B, because you can check for polonium. Polonium is 216 minus 84. That's 132. So the answer is B. An atomic nucleus emits a beta particle. What change does this cause to the proton number and nucleon number of the nucleus? An atomic nucleus emits a beta particle. Remember I said when it is beta particle, it is beta minus. So let's say nucleus X emits a beta particle to form nucleus Y plus beta minus 0, negative 1. So this is Z is going to increase by 1, and this is A does not change. So nucleon number does not change, but Z increases by 1. So proton number is plus 1. The answer will be D. Which statement concerning alpha particles is correct? An alpha particle has a charge of positive 2e. Not true. The charge is positive 2e. An alpha particle is a helium atom. Not true. It is actually a helium nucleus. An alpha particle travels through air. They cause ionization. That is very true because they have charge of positive 2e. When alpha particles travel through a sheet of gold foil, they make the gold radioactive. That is not true. So the answer is going to be C. A nucleus of nuclide Pu24194 decays by emission of beta particle followed by the emission of an alpha particle. Which nucleus is formed? So let's say Pu24194. It first of all emits, decays by emission of a beta particle. So it is beta 0, -1 plus a new nucleus. Let me call it X. So X is going to have 241 and this will be 95. Then X also decays to form Y. So this is 24195 followed by emission of alpha particle. So this is plus alpha, which is 42. So this becomes 241 minus 4, which is 237, and 95 minus 2, which is going to be 93. So this gives us NP 23793. What are the correct descriptions of gamma ray and a beta particle? Gamma high-speed electron, that is not true, so A is out. Gamma is electromagnetic, so we remove D also. Then beta is a helium nucleus, that's not true. Beta is an electron, so the answer is C. What is not conserved in the nuclear process? Charge, momentum, total number of neutrons. Momentum is always conserved. Neutron number is always conserved. The neutron number is always conserved. No, it is the nucleon number which is always conserved. The neutron number may not be conserved, but the charge is always conserved. The question is, what is not conserved? Charge is always conserved because the charge is determined by the number of protons. So the neutron number is the one which is not conserved. So the answer is C. Charge determines the number of protons, so proton number is conserved if the charge is conserved. Or if the proton number is conserved, the charge is conserved. Momentum is always conserved. Mass energy, nucleon number. So it is the total number of neutrons that may not be conserved. The following represents a sequence of radioactive decays involving 2 alpha particles and 1 beta particle. What is the nuclide X? So here alpha particle is 42. So this one has 213, we subtract 4, 85 minus 2, that is 83. Again another alpha particle, minus 4, it will be 209. Then proton number minus 2, it will be 81. Then beta particle is 0, -1. So this is 209, it remains 209. And this one increases by 1, so it will be 82. So the answer here is going to be C. Uranium-235 may be represented by that symbol. Which row shows the numbers of nucleons, protons, and neutrons in uranium-235? Protons, they are 92. So we ignore A and D. Nucleons, they are 235. Nucleons, 235. So nucleons are 235, so we ignore B, we remain with only C. 235 nucleons, 92 protons, 143 neutrons. Which nuclear equation shows beta decay, the beta decay of a nucleus of argon into potassium K? Let's check. Here proton number was reduced by 4, here was by 2 for a helium nucleus. Okay. Which nuclear equation shows the beta decay of a nucleus of argon? So this is not a beta decay, that is alpha decay. This one, proton nucleon number did not change. Proton number, this is a beta plus. Remember I said when they say beta decay, they are referring to beta minus. Then this one, This is 18, 19 plus -1, that is 18. So this is beta minus, so this is the beta decay. Therefore, the answer is C. I am repeating, when they just say beta decay or beta particle, they are referring to beta minus. That's why we couldn't choose B, but we chose C. The last one is not a beta decay, that is a gamma decay. In Rutherford's scattering experiment, alpha particles were fired at a thin gold fell. A small proportion of alpha particles were deflected through large angles. Which statement gives the correct conclusion that could be drawn directly from these results? The atom is made up of electrons, protons, and neutrons. We can't draw this directly from the results. The nucleus is at the center of the atom. We may not draw this directly from the results. The nucleus is made up of protons and neutrons. We need another experiment to verify this. The atom contains a very small charged nucleus. That is true. We may not know whether it is exactly at the center, but we know it must be very small and charged. So the answer is D. We can draw this directly from the alpha scattering experiment, that the nucleus of an atom is very small and charged. Which statement about the nuclei of atoms of an element is correct? Which statement about the nuclei of an element is correct? Every nucleus of an element contains an equal number of neutrons and protons. That is not true. Sometimes the number of protons is greater than the number of neutrons, or the reverse. Every nucleus of an element contains the same number of protons, neutrons as all others of the element, but the number of protons may differ. That is not true. Every nucleus of an element contains the same number of protons. Every nucleus of an element, same number of protons as all others for the same element, but the number of neutrons may differ. That is true if they are isotopes. The number of protons in a nucleus differs from isotope to isotope. No. For isotopes, they have the same number of protons. A counter recording radioactive decays from a radioactive source gives the following counts in equal intervals of time. 0 to 10, the count is 424. 10 to 20 is 395. 20 to 30 is 413. 30 to 40 is 362. You see that the time intervals are the same. It is a time interval of 10 minutes. But you see that the counts are actually different. That is because radioactivity is random. So let's see the question. What can be deducted from these readings? The radioactivity is random and that the half-life is 90 minutes. Let's see. Is the half-life 90 minutes? 424 divided by 2, divide by 2. The initial count rate is 212. But we don't know the initial count rate at t equals to 0. So this is the count rate after 10 minutes. So this is not true. We cannot have a conclusion that the half-life is 90 minutes, not at all. But we can conclude that the radioactivity, we know that the radioactivity is random. So first of all, eliminate C and D because for them they are talking about spontaneous, yet it's supposed to be random. The radioactivity is random and that the half-life is uncertain. This could be the most appropriate one. We cannot predict the half-life from these values. The half-life is uncertain. In what way do the atoms of the isotope carbon-12, carbon-13, and carbon-14 differ? They differ the neutron number. They have the same charge. Different charge, that's not true. They don't define charge. They have the same number of electrons, so they don't define electrons. They have the same number of protons. They don't define in protons, so they are only differing in the number of neutrons. So they define number of neutrons. Strontium-90 is radioactive and emits beta particles. Which equation could represent this nuclear decay? It emits beta particles. That is beta minus. When they say emits beta particles, just notice beta minus. So we ignore these. We ignore these two. Ignore these two because they are emitting positrons. Then we look at the balance and check the equations. So this is 38, 39 minus 1, that is 38. So this is balanced. Then let's see this one, 38, 39 minus 1, that is balanced. 90, 90, that is balanced. So this has emitted, the proton number has changed, and we are seeing the proton number is different, but they say strontium is radioactive and emits beta particle. And here we are seeing it has remained strontium with 90 and 39, yet the proton number has changed and it has remained strontium, which is not possible. So this is going to be B. It can't be A because if the proton number has changed, it cannot remain strontium. Unless if the nuclear number changes but the proton number has not changed, then it can remain strontium. So the answer is going to be B. Because the proton number has changed, so it must be a different element. I mean, it must belong to a different element. Protons and neutrons are thought to consist of smaller particles called quarks. The up quark has charge 2 over 3e. Down quark has negative 1 over 3e, where e is the elementary charge, 1.6 times 10 power negative 19. How many up quarks and down quarks must a proton contain? We know that a proton has up, up, down, up, up, down. So there are 2 up quarks and 1 down quark. So that one, the answer is D. Which set of radioactive emissions corresponds to descriptions given in the table headings? High-speed electrons. Alpha is not high-speed electrons. Those are helium nucleus. It is beta particles. High-speed helium nuclei. Beta is not helium. Gamma is not helium. It is only alpha. High-frequency photons, that is gamma. So the answer is going to be C. The nucleus of one of the isotopes of nickel is represented by that symbol. Which line in the table correctly describes a neutral atom of this isotope? If it is neutral, it must have the same number of electrons as the number of protons. So we first eliminate 32. We first eliminate D. We look at the number of electrons. So number of protons of nickel is 28. So we eliminate this one, which is saying 60. We remain with A and B. So number of neutrons should be 60 minus 28, which is 32. So the answer is going to be A, not B. The answer is going to be A. A nucleus of barium decays to Mendelevium by a sequence of 3 alpha particles. So it first decays by giving an alpha particle. So this one is going to be, we subtract 4. So it is X minus 4 and Y minus 2. Then Lawrencium, again with another alpha particle, so we shall still say minus 4, then minus 2 on Y. Then Mendelevium plus another alpha particle, so minus 4 again, minus 2. So we just equate this one to the nucleon number, which is going to be 255 to find X. So 255. So the question is, how many neutrons are there? Let's first find number of protons. So this one should also be equal to 101. So proton number is going to be 101 plus 6. That's 1. Y is 107. Then nucleon number is going to be 255 plus 444. That is 12. So X is going to be 267. 267. Then we subtract 267 minus 107, that gives us 160. So number of neutrons is going to be 267 minus 107, which is equal to 60. 160. So the question is, how many neutrons are there in nucleus of XYBH? So the answer is going to be C. A nucleus of the nuclide Pu decays by emission of beta particle followed by the emission of an alpha particle. Which of the nuclides shown is formed? So you see, this is a question we have just answered. So Pu 24194 decays by emission. Let's say it gives us X plus beta, which is 0, -1. So this is going to be 241. Then this is going to be 95. Again, X 24195 decays by emission of alpha to give Y plus alpha, which is 42. So this is going to be 241 minus 4, which is 237, and 95 minus 2, which is going to be 93. So the answer is C. A thin gold foil is bombarded with alpha particles as shown in the figure. The results of the experiment provide information about the binding energy of the gold nucleus. That's not true. Energy levels, that is not true. Size of the gold nucleus, that's not true. Yes, it's the structure of the gold nucleus, so the answer is C. The nucleus is very small. It occupies a very small volume, so the answer is C. Size of the gold nucleus, very small, occupies a small volume of the atom, so that is C. Because the results are showing that most alpha particles are actually going through, because the atom, the nucleus is very small, but those which come close undergo large deflection. You see a few are backscattered, those which come very close to the nucleus. Isotopes of a given element all have the same proton number. Isotopes, same proton number. Which two nuclei contain the same number of neutrons? So this is different. Let's check this one. 16 minus 7, that is 9. 15 minus 8, which is 9. So the answer is going to be which two nuclei contain the same number of neutrons? 15 minus 8. No, that is not 9. It is actually 7. 23 for sodium. 23 minus 11, that is 12. And 24 minus 12, that is 12. So the answer is going to be C. Same number of neutrons. A student conducts an experiment using an alpha particle source. When considering safety precautions, what can be assumed to be the maximum range of alpha particles? These ones have a few centimeters, about 6 centimeters in air. So considering safety, 6 centimeters is going to be this is 5 millimeters, 0.6 centimeter, 0.5 centimeters, that is too small. Between 5 and 200 millimeters, those are 200 divided by 10, those are 20 centimeters. So the answer is going to be B. The range of alpha particles in air is approximately 6 centimeters, so it is between 5 and 200 millimeters. This one could be a beta and the other one could be gamma, but gamma has a wide range in air. The following represents a sequence of radioactive decays involving 2 alpha particles and 1 beta particle. What is nuclide X? So we have answered this question. Alpha is, remember, 42. So this one we would subtract by 4, 213, and proton number by 2 to be 83. Again by alpha, subtract 4, 209, proton number by 2, 81. beta is 0, -1. So this remains 209. Proton number increases by 1 because of the negative, so that would be 82. So proton number 82, nucleon number is 209, so the answer is C. A detector is exposed to radioactive source. Fluctuations in the count rate are observed. What do the fluctuations indicate? Fluctuations indicate a random nature. So they said it is random, spontaneous, exponential, nonlinear. So the fluctuations is the random nature. The symbol Ge7732 represents a nucleus of germanium that decays to a nucleus of arsenic by emitting a beta particle. What is the symbol of the arsenic nucleus? Let's just find the proton number and nucleon number first. Ge7732. It is emitting X by beta particle, so it is beta 0, -1. So this remains 77. It means all these ones are wrong because the nucleon number is not supposed to change. So it means the answer is only D, because this will be 32, the other one will be 33. Each of the nuclei below is accelerated from rest through the same PD. Which one completes the acceleration with the lowest speed? Which one completes the acceleration with the lowest speed? Each of the nuclei below is accelerated from rest through the same PD. Which one completes the acceleration with the lowest speed? So we have H11, proton number is 1, no neutron. H21, proton number is 2, neutron number is 2. And lithium 73, proton number is 3, and the nucleon number is 7. So they're saying which one completes the acceleration with the lowest speed? Which one? Each of the nuclei below is accelerated from rest. So of course this is under electric fields. So force is equal to mass times acceleration, but force is E over charge, and E is equal to V over D. So it means the mass, okay, the acceleration ma is going to be equal to I want to bring in Q and V. So ma, or acceleration, is equal to E over Q, and also ma is equal to V over D. So they are accelerated through the same PD. So V is constant, this D will also be constant, and it means the acceleration is equal to E divided by m times Q. So the acceleration is depending on E, m over m times Q. It is actually inversely proportional to the product of the mass and the charge. So in this case, if they are accelerated through the same PD, E is constant. So because E is V over D, so I will say MA is equal to E, which is V over D. So that will be V over D times Q in the denominator. So I will say A is equal to V over MD times Q. Okay. So if V is constant and D is the same, it means A is inversely proportional to M and the product of M and Q. So the product of M, the mass of lithium, is going to be 7U times Q. The charge is 3E. Then for beryllium, the product of the mass of beryllium is going to be the product of beryllium, the mass is going to be 9U times the charge, which is going to be 4E. So it means beryllium because acceleration is inversely proportional to the product. Because the product is greater for beryllium, so here the answer is going to be D. Okay, I'm doubting this. I think I should use charge to mass ratio. I think I used this wrong relationship here. Force is not, it is, E is the one which is F over Q. My instincts tell me that that is wrong. E is F over Q and E is V over D. Yes. So it means F is equal to Q V over D. Yes. So F is MA. MA is equal to Q V over D. Yes. Same PD. This is a mistake. I think I used the wrong expression. So this is not true. So acceleration is going to be Q V over M times D. Yeah, I've been thinking about mass to charge ratio. So charge to mass ratio, the one with a high charge to mass ratio has the highest acceleration. The one with the smallest charge to mass ratio has the smallest acceleration, because acceleration is directly proportional to the charge mass ratio when V over D is constant. So we can check. Here the charge to mass ratio, charge is 1, the mass is 1. Here the charge is 2, the mass is 4U. Here the charge is 3, the mass is 7U. Here the charge is 4, the mass is 9U. So you see that when you check 3 divided by 7 is 0.4, 4 divided by 9, 0.44. Then 2 divided by 4, 0.5. And then 1 divided by 1. So this is 1, this is 0.5, this is 0.3 divided by 7, 0.43, and this is 0.44. So it means the one with the smallest charge to mass ratio has the smallest acceleration. So the answer is C. It's not D. The one with the smallest charge to mass ratio has the smallest acceleration. But I say this part of the question, this part is now in electric fields, which is now purely A level. That's electric fields, which is purely A level. But the answer is C. What is the approximate mass of a nucleus of uranium? So we have already seen that this is 10 power negative 25. Why? Uranium is normally written as 235 or 236 or 238. So it is the mass is 235U, which is 235 times 1.66 times 10 power negative 27, which gives us a power of negative 25. So the answer is C. How do the nucleon number and proton number of two isotopes of an element compare? Proton number must be the same. So we take same, we ignore this one, these two. Then nucleon number, different, same. If the nucleon number cannot be the same, they must be different. So the answer is B. Nuclear decay is both spontaneous and random. When the count rate of a radioactive isotope is measured, the readings fluctuate. Which row describes what the fluctuations demonstrate? Fluctuations demonstrate specifically random. Spontaneous nature? No, no, no. Random nature? I said the fluctuations represent random nature. So that is yes. The fluctuations represent the random nature. That is yes. Do they represent the spontaneous nature? That is no. So the answer is going to be B. Fluctuations do not represent the spontaneous nature. They represent the random nature. They don't represent both spontaneous and random. So the answer is B. Okay. Which two nuclei contain the same number of neutrons? Neutrons. So here they can't be the same when you subtract. Here it is 9, and here 15 minus that is 7. That is no. This is 23 minus 11, those are 12. 24 minus 12, those are 12. So the answer is C. The calcium nuclide is formed by beta decay. What are the nucleon number and proton number of unstable nuclide that underwent beta decay to form calcium? So X is decaying to form calcium 42, 20. It is formed by beta decay. So this is plus beta 0, -1, because always it is beta minus. So this is 42. Nucleon number should remain 42. These two are eliminated. Proton number is going to be, because this is 19, 20 minus 1 is 19, so this side should also be 19, so the answer will be C. Which nuclear equation could represent the reaction? Which reaction? When boron is bombarded with an alpha particle. So boron is bombarded with an alpha particle, which is He42 or alpha 42. A new nucleus is formed and a neutron. So let's say what is formed is X plus a neutron, which is N10. So X should be, because this is 11 plus 4, which is 15, this should be 14. Because this is 5 plus 2, which is 7, this should be 7. So X should be 14, 7. This is wrong, this is wrong, this is wrong. So the answer is D. In an experiment to investigate the nature of the atom, a very thin gold film was bombarded with alpha particles. What pattern of deflection of the alpha particles were observed? A few alpha particles were deflected through angles greater than right angle. That was true. Alpha particles were deflected from the original path. Okay. Alpha particles were deflected from their original path. Most alpha particles were deflected through angles greater than right. That is not true. No alpha particle was deflected. That's not true. So the most appropriate answer is going to be A. Even though the second one, all alpha particles were deflected from their original path. Not all. Those which were very far from the nucleus could have passed through without being deflected. A nucleus, uranium absorbs a slow neutron. It subsequently emits two beta particles. What's the resulting nucleus? So we say uranium 23892. It is emitting it subsequently emits two beta particles. So that is 2 beta minus 0, -1, plus, let's say, nucleus X. So proton number is going to be 2 times -1, that's -2. We add it to 92, this will be therefore 94. And this remains 238. So this should be 94. So that is going to be, when a nucleus absorbs a slow neutron, so there is a +1 neutron this side, so N10. So this is 239, not 238. So this is 239. So the answer is going to be C. Which are the correct descriptions of gamma ray and beta particles? So we're now repeating the questions. We know that gamma is electromagnetic, so these ones are eliminated. And then beta are high-speed electrons, so the answer is C. A certain nuclide, uranium-235, has nucleon number 235, proton number 92, and neutron number 143. Data on 4 other nuclides are given below. Which is an isotope of uranium-235? Proton number is 92. An isotope must have the same proton number as 92. So proton number 92, the nucleon number should be different. So the answer is most likely going to be B, because proton number should be the same. If uranium has proton number 92, its isotope should have the same proton number. So the answer is B. A nickel can be transformed by a process of termed K capture. That is another repeated equation. In this process, the nucleus absorbs an orbital electron. So let's see. Nickel 5928, it is absorbing an electron, that is K capture. So this gives us a nucleus X, which has nucleon number 59. Proton number should therefore be 27 to balance. So the answer is going to be cobalt, CO. The symbol germanium represents a nuclide, germanium, that decays to a nuclide of arsenic by emitting a beta particle. What is the symbol of the arsenic nuclide? We are repeating this question again. So germanium, Ge7732, represents a nuclide of germanium that decays to As by emitting beta particle, which is 0, -1. So this one should remain 77, but this one increases to 33. So the answer is D. The table shows 3 properties of different types of ionizing radiations, X, Y, and Z. Charge 00C, speed is C. Mass 0, 1 over 1840 U, Z 4U. What are the radiations X, Y, and Z? So this one, Z must be an alpha particle. This one must be fast moving electrons. This should be gamma radiations. So X is gamma. We eliminate X-rays and alpha. Y is beta. Y is beta, so we eliminate alpha. Z is alpha, we eliminate this one. So the answer is going to be C. Which conclusion can be drawn from the results of the alpha experiment showing the scattering of alpha particles? Electrons orbit the atomic nucleus in well-defined paths. That one cannot be concluded from the alpha. Nuclei of different isotopes contain different numbers of neutrons. We can't conclude this from the alpha scattering experiment. The atomic nucleus contains protons and neutrons. We can't conclude this from that experiment. The nucleus is very small compared to the size of the atom. That one can be concluded from that experiment. A nuclear reaction is represented by that equation. What is particle X? Let's balance. This is 8 plus 2, which is 10. This is 9, so this should be 1 to make it 10. This is 16 plus 4, which is 20. So this should be 1 to make it 20. So X is going to be a proton. X11, because this should be 1 to balance the nucleon number and 1 to balance the proton number. X is most likely going to be a proton. Which statement concerning alpha particles is correct? Charge positive 2e, that is not true. It is positive 2e, not 4e. An alpha particle is a helium atom, not true. It is a helium nucleus. When alpha particles travel through air, they cause ionization. That is true. So the answer is C. When alpha particles travel through a sheet of gold foil, they make the gold radioactive. That is not true. Where are electrons, neutrons, and protons found? Electrons revolve around the nucleus. The neutrons and protons are found in the nucleus. So electrons, they are not in the nucleus. Neutrons, they are in the nucleus. They are not orbiting the nucleus. They are in the nucleus. So we have already eliminated A and B because it was saying electrons are in the nucleus. So electrons orbit the nucleus, the neutrons are inside the nucleus, the protons are also inside the nucleus. So the answer is D. How is it possible to distinguish between isotopes of uranium? How is it possible to distinguish isotopes of uranium? Remember, they have the same proton number. Their nuclei have different charge and different mass, and they emit different particles when they decay. That's not true. Their nuclei have the same charge because they have the same proton number. Their nuclei have different charge. That is not true. They have the same charge because they have the same proton number. Their nuclei have the same charge. That is true, but different masses. That is very true because they can differ in nucleon number. Their nuclei have the same charge and mass. The mass is not the same, but they emit different particles when they decay. So the answer is C. What is not conserved in a nuclear process? Nucleon number is always conserved. Charge is always conserved because it is proton number. Energy and mass together, that is mass energy conserved, is only the neutron number which may not always be conserved. The neutron number may not be conserved because changing the neutron number does not affect anything. So the neutron number may not always be conserved. A thin gold foil is bombarded with an alpha particle. So this is alpha, as shown in the figure. So these are incident alpha particles. What can be deduced from this experiment? The binding energy of the golden nucleus? No. Energy levels? No. The size of a golden nucleus? Yes. We know that this can help us to tell that the golden nucleus occupies a very small volume of the atom. Zirconium nucleus ZR140 is an alpha, or it is I think that is a beta. I think it is an alpha emitter. No, this is going to be a beta, not alpha. You can't say is a alpha emitter. I think it doesn't make good sense to say is a alpha emitter. That must have been beta. That is a beta emitter. The product nucleus is also a beta emitter. Let's also add a beta emitter there. That is missing. What is the final resulting nucleus of these two decays? Beta emitter, proton number increases by 1 because beta is 0, negative 1. So proton number, the first one, proton number is plus 1. So it is 40 plus 1. Then again, the product nucleus is also a beta emitter. Again, the product proton number increases by 1. So it becomes 42. Nucleon number does not change. So these two are wrong. Then these ones, proton number increases. So that will be B. The following particles are each accelerated from rest, the same potential difference. Which one completes the acceleration with the greatest momentum? Greatest momentum. So this must be an alpha particle. The other one is electron, neutron, proton. So acceleration is equal to force over mass, and the force is equal to electric field strength over charge. So this is Q over M. And charge is equal, E is V over D, so this is V over D, Q, no. Force is, E is force over Q. So E is force over Q, so force is equal to EQ. So this is EQ, not E over Q. I don't know why I'm making this mistake every time. So acceleration is F over m, that is E Q over m, and E is V over D, so that is V over D times m. V over D times m, then times Q. So we need the charge to mass ratio. The one with a greater charge to mass ratio has a greater acceleration. That means it has a higher velocity, has a higher momentum. So we can check. Proton, charge to mass ratio, the charge is 1, mass is 1u for proton. Neutron, the charge is 0, the mass is 1u, so that one is 0. There's no acceleration. The electron, the charge is negative 1, the mass is 1 over 1840u. So this one goes up, it becomes 1840u times the charge times E. Then the alpha is the mass, the charge is 2e, then divide by 4u. So we see that the electron has the highest charge to mass ratio of 1840 u times E. I'm been dividing the charges. For an electron, it is negative 1e over its mass, which is 1 over 1840 u. For the neutron, charge is 0 over its mass, which is 1u. For the proton, charge is 1e over its mass is 1u. So we see that for an electron, when you get the reciprocal of 1 over 1840u, it has the greatest charge to mass ratio. So the question is, which one completes the acceleration with the greatest momentum? And I'm seeing for the electron, for the same PD, the electron has but this is the mass is 4u. The speed is approximately 1 point. Okay, you can check this with the speeds. The mass of an electron is 1.6 in 9.11 exponent negative 31. Because they are accelerated through the same PD, they have the same kinetic energy. No, kinetic energy is charge times V. The kinetic energy is EV. Let me concentrate on this. Which one is bigger here? So this is going to be 2E. Which one has a bigger charge to mass ratio? So negative 1E over 1 over 1840. Oh, sorry, this is negative, so this will be a deceleration. So the answer is going to be A. Because of the negative, and this will be negative 1840. That means the acceleration is going to be a negative value, but normally we ignore the charge. We can also check this from the values that we already know. For example, the speed of an alpha particle is approximately of the order 10 power 7 meters per second, or 0.1 or 0.05 cc, and the speed of an electron is high, but its mass is extremely small. So if you look at the mass of an electron as 9.11 times 10 power negative 31 times the speed, which is approximately 0.99 c 3 exponent 8, you see that its momentum is going to be very, very small. We can check the alpha particle. The mass is 4u. That is 4 times 1.66 exponent negative 27. Then times its speed is approximately 0.055 c times 3 exponent 8. So you see that its momentum is actually going to be greater. So the answer is going to be A. Alternatively, you can relate this to charge to mass ratio. Which conclusion can be drawn from the results of the experiment showing the scattering of alpha particles by gold failed? Electrons orbit the atomic nucleus in well-defined paths. We can't conclude that. Nuclei of different isotopes contain different number of neutrons. We cannot conclude that. The atomic nucleus contains protons and neutrons. We cannot conclude that using the alpha scattering experiment. Other experiments are needed. The nucleus is very small compared with the size of the atom. That is true. The nucleus occupies a very small volume. A nucleus Q has the notation QYX. Which of the following is an isotope of Q? So the proton number should still be X. So the answer is going to be A, same proton number. Uranium, a uranium-238-92 nucleus decays in two stages to Pa nucleus. What was emitted in these two stages? So we see the proton number the nucleon number has reduced by 4. The proton number has reduced by 1. So let's see, uranium 238, 92. Let's say it emits Pa 234, 91 plus X alpha particles plus Y beta particles. Let's say it emits X alpha particles 42, beta particles 0, negative 1. So we can find the number of alpha particles because this reduces by 4. So and yet beta particles do not affect the number of nucleons, yet it has reduced. So C is wrong and D is also wrong because D's beta and gamma, they don't affect the number of nucleons, yet the number of nucleons has reduced by 4. So one alpha particle must have been emitted, X is equal to 1. An alpha particle is emitted, but then the proton number on the left hand side is 92, on the right hand side it would be 91 plus 2, which is 93. So we must subtract 2. We must subtract an alpha minus 1. That means y will be equal to 1. So another beta particle is going to be emitted. So it is alpha and beta, which makes this to be A. The gold nucleus undergoes alpha decay. What are the nucleon number and proton number of the nucleus formed by this decay? Proton number reduces by 2. So that is 77. So we have these two. We eliminate this one and this one. Then we want nucleon number. Because it emits a gold nucleus, it emits an alpha particle, nucleon number reduces by 4. So that will be 181. The answer will be C. And lastly, the nuclei of the isotopes of an element all contain the same number of a certain particle. What is this particle? The nuclei of the isotopes of an element contain the same number. Those contain the same number of protons. That will mark at the end of nuclear physics, particle physics and atomic physics. Note how many times many questions have been repeated. That is enough to let you know that actually there are fewer questions in particle physics. That's why even the last 3 or 2 questions will always be particle physics. I hope you learned something from this. In case of any errors, just know that I am human. I'm bound to make errors. Nevertheless, I have tried my level best and I wish you the best. Thank you. Bye bye.